Hello and welcome to Tribe Topper. In this video session, you are going to learn about banking of roads. You might have seen sometimes for the racing tracks or the roads on the hills, they have their outer edge raised a bit. Like I would say the tracks for motor or cycle racing and even the ordinary roads which are generally in the hills, they are sometimes banked. So banking is basically raising the outer edge of a road. The curve of the banked road surface is inclined, like because it is raised, this is the road, then it is raised outwards, then this is the angle of banking. Now we in this topic we have to figure out this angle of banking. So we say that the curve of the banked road surface is inclined at an angle so that the normal reaction force contributes to the centripetal force which is needed for the vehicle to go round the track at a particular speed. Now here, first of all, let's label all the forces that are acting. So the forces that are acting is, one is marked clearly mg, acting downwards. The normal reaction, it is always normal to the surface of contact. So do not draw a straight line vertically upwards in this case because your surface is inclined. So the normal reaction is this way, n. Now this is inclined at an angle theta. So we have one component n, since it is inclined at an angle theta here, so the other side theta would be formed at this side. So you have this way n cos theta, and the other side, the horizontal component, is n sine theta. As you can see that your n cos theta is being balanced out by the weight. So they are balancing each other. There is no vertical motion of the car. Let's mark this equation 1. And n sine theta is providing, this is acting inwards, this is going to provide the necessary centripetal force for the car to take a turn. So n sine theta is providing the centripetal force, so we'll equate it with mv square by r. Now we divide the equation 2 by 1. What do we get? We get n sine theta upon